In this lesson, we're going to focus on the volume of pyramids and cones. We're basically building off on what we did in the last lesson. In the previous lesson, we talked about finding the volume of cylinders and prisms. And in fact, we're going to use that knowledge to help us find the volume of cones and pyramids. So we'll start off by defining the two shapes. So a cone is a solid that has a circular base and a curved side ending up in a tip. What about a pyramid? A pyramid is a solid with a polygon for the base and lateral faces are triangles. So I've shown you some pyramids here. This pyramid has a base which is in the shape of a triangle, and this pyramid looks like its base is a square. You can't really tell for sure, but well, let's just say it's a square. Now in this course, what we're going to do is we're going to focus on pyramids with a base which is a square. There are other pyramids, but we're going to focus on the ones with a base that is a square. Okay, so if I had some cones and pyramids in front of me, I'd actually build a relationship between the volume of cones and pyramids with cylinders and prisms. Okay, so I'm gonna try to draw a picture. Okay, so you know what? Let's work with a cone first. So I have this beautiful cone here. Okay, and I'm going to try my very best. I'm going to try to draw a cylinder right beside this cone. Let's try. Okay. Wow, this is not very nice, but you know what? Okay, we're gonna have to use our imagination. Okay, so we'll say this is R, the radius of the circular base, and the height is the height of the cylinder. Ooh. Okay, you know what? We'll live with that. We'll live with that diagram. So we have to use our imagination. I know they don't look the same at all, okay? But can you use your imagination and say that this circular base of the cylinder is exactly the same as that of the cone? And can you also use your imagination and say that the height of the cone is exactly the same as the height of the cylinder? Okay, so what we're going to say, because the radius of the cylinder and the cone are the same, and the height of the cylinder and the cone are the same, we say that these two shapes are related. These two, the cylinder and the cone, are related. So when the cylinder and the cone are related, how are the volumes related? What's the relationship between the volumes of these two related shapes? So if you can imagine, I filled this cone with water. I know it's upside down, but you picked it up and you filled it with water and you poured it into the cylinder. Now, how many times do you have to fill this cone how many cones are going to pour into the cylinder in order to fill in the cylinder? Okay, so imagine you're filling up this cone and pouring it into the cylinder. How many times do you think you have to do that in order to fill up that cylinder? Well, The answer, I wish we had the manipulatives in front of us, but the answer is 3. If you fill up this cone, okay, but they must be related, which means the radius of the two shapes must be the same, and the heights of the two shapes must also be the same. So if the cylinder and the cone are related, then the volume of the cone is exactly 1/3 of that of the cylinder. Okay, so we're actually going to make the exact same relationship with the square base pyramid with, hope you can imagine, what am I going to draw? This one looks pretty, actually it's not that bad, not that good, because I want to show that they are related. So these two are related. So this is the square base pyramid, and this is the square base prism. Now I'm saying they're related. Now if they are related, guess what? The area of the bases are the same. Okay, this square is identical to this square, and the heights of the pyramid and the square base prism are also the same. So if they are related, what's the relationship of the volume? Just like last time, the volume of the related pyramid is 1/3 of that of this prism. So if this, it doesn't matter if it's square base, but since in this course we focus on square base pyramids, so the volume of the square base pyramid is exactly 1/3 of the related volume for the square base prism. And we wrote it down here. So that's why you take the area of the base times the height. This is the formula for the cylinder or the prism, and you just divide it by 3 because it's 1/3 of the volume of that related shape. Here's the formula sheet, or a section of it at least. 1/3 pi r squared h, because pi r squared h is the volume of the cylinder, right? So just take 1/3 of that. So that will give you the volume of the related cone. And this, take 1/3 of b squared h. It will take 1/3 of the related volume, which is the square base prism. So 1/3 of that, the volume for that square base prism related to this square base pyramid. Okay. And that's why we learned about prisms and cylinders earlier, before we talk about pyramids and cones. It's a perfect transition. Alright, so let's do some questions here. So we have a square base pyramid. So volume of a square base pyramid is 1/3 b squared h. So 1/3, in this case it's 5 squared, and the height is 7. So let's see. 58.3 about cubic centimeters. For this one, let's just write down the formula. So this is the cone 1/3 the volume of the related cylinder. So this would be pi r squared h. Ooh, wait a minute. I don't have the radius. I have the diameter. So let's do a quick calculation. The radius is equal to, you can say diameter divided by 2. So in this case, radius is 14/2, which is 7. Okay, please don't use the diameter to find the volume of a cone. And the height is 22 centimeters. Just punch that into your calculator. Uh, 1128.9. and cubic centimeters. Okay, let's see. A square base prism has a volume of 1,500 cubic centimeters. What is the volume of the largest pyramid that can fit into this prism? Okay, so it just fits in. Basically, they're asking you for the volume of the related pyramid. What is the volume of the related pyramid? So hopefully remember the relationship we talked about earlier. The volume of the related pyramid is exactly 1/3 of the volume of that square base prism. So the volume, let's just do V is equal to 1500 divided by 3. That's 1/3. So it's 500 cubic centimeters. The volume of the largest pyramid that can fit into the prism is 500 cubic centimeters. Okay, so now we have another question. When small stones pour off a conveyor belt, they form a pile that has the shape of a cone. The height of the pile is the same as the diameter of the circular base. The radius of the pile is 18 meters. Determine the volume of the stones. Okay, so let's write down the formula. Pi r squared h, 1/3 pi r squared h. Okay, and they said the height is the same as the diameter. So diameter is twice the radius. So if the radius is 18, if the radius is 18 meters, then the diameter must be 36 meters. So 1/3 pi, r is 18, and height is 36. There's a lot of stones here. So we're looking at 12,214.5 cubic meters. If these stones are placed into cubes with a side length of 2 meters, how many cubes should be filled with could be filled with this pile? Okay, so what I'm going to do is going to find the volume of 1 cube. Okay, so if the cube has side lengths of 2 meters, this is a huge cube, by the way. What's the volume of 1 cube? So volume of cube is equal to a side length cube, because the length and the width and the height of a cube are identical. So 2 cubed, 8. So the volume of 1 cube is 8 cubic meters. Okay? So if the volume of 1 cube is 8 cubic meters, how many cubes can I fill? Well, what's the volume of the stones? 12,214 about. So the number of cubes filled equals 12,214.5. Okay, and since each cube is 8 cubic meters, I'm going to take that and divide it by 8. And let's see how many cubes I can fill. So we're looking at about 1526.8. So therefore, we can fill 1,500. Should it be 27 or 26? So hopefully you're going to say 1,526 cubes. We can only fill 1,526 cubes because you couldn't fill the 1,527th cube, right? You're just shy. You just can't fill that last cube. You have to round down here. Even though you're really close to filling that last cube there, you don't have enough stones. So you find the volume of one cube, and then you take the total volume of stones and divide it by 8. Because that will tell you how many cubes you can fill. So you end up filling 1,526 cubes. Okay, so this lesson is basically a continuation of the big journey, which is finding the volume of different shapes. But I also want you to see the relationship between what we did in the previous lesson and this lesson. Okay, we talk about related shapes. So we're talking about cylinder and cone and how those are related, as well as pyramid and rectangular prisms.